Good morning and a very warm welcome to everyone joining us for the panel discussion session of International Engineering Education Symposium 2025. I'm Rajesh and I have an honor and privilege of serving as session coordinator for the discussion session. It is my privilege to present to you all our panel members. I have Zairul, Amri, and Zakaria, Director of Engineering Accreditation, Department of Engineering Accreditation and Engineering Technology Accreditation Council, Board of Engineers of Malaysia. Then we have Professor Krishna Vedula. He's a professor and dean in UMass Lowell of United States of America. And then we have Dr. Javeed Kittur, Engineering Pathways, Gallogly College of Engineering, the University of Oklahoma. Now, I'd like to briefly talk about our honorable panel chair, Dr. Abdul. Dr. Abdul is a leading expert in materials engineering and professor of Department of Nanomaterials and Ceramic Engineering at BUET. He earned his BSc and MSc at Metallurgical Engineering from BUET and completed his PhD at KU Leuven in Belgium. He spent over 16 years in the University of Malaya, where he served as the Dean of Innovative Industry and Sustainable Research Cluster as Associate Vice Chancellor for Industry and Community Engagement, overseeing major research, industry collaboration, and academic developments. Dr. Haseeb's research covers oxide-based nanostructures for gas sensing, electronic packaging materials, and materials degradation in extreme environments. He is also a fellow in UK's Institute of Mechanical Engineers, a chartered engineer, UK's Engineering Council, and a member of both TMS and IEEE, which are from the United States of America. Internationally recognized, he has held prestigious fellowships at Oxford University, Casper Institute of Technology, Kyushu University, and ETAC in Argentina. He is also the editor-in-chief of Elsevier's Encyclopedia of Materials, Electronics, and serves on the editorial boards of several leading scientific journals. So without further ado, I'd like to hand the session over to our chair, Dr. Abdul.
Thank you very much, and welcome to you all. Am I audible? Can everybody hear me?
Yes, sir.
Okay, great. So we are looking forward to an exciting panel discussion today, and we have three distinct, highly distinct panel discussion. The first being engineer Zairul Amri Zakaria. Professor Sadrul Islam sent us his regret. He cannot make it today. So we have our speaker, Professor Krishna Vedula, who will be the second. And the third speaker will be Dr. Javeed Kittur. And before we start, let me just give you a very brief introduction to engineer Zairul Zakaria. He received his education in Cardiff University and Kingston University in the UK. Then he joined there and he served as mechanical design engineer and later operations director. He eventually returned to Malaysia, and then he dedicated his efforts towards his engineering education. He's currently the director of the Engineering Accreditation Department at the Board of Engineers, Malaysia. And he spent a lot of his time and efforts in doing the accreditation internationally. He contributed towards Washington, Sydney, and Dublin Accords and participated there in the review processes of engineering programs. He also contributed towards international efforts on engineering accreditation, like in Pakistan and in other countries. So I would like to invite engineer Zairul Zakaria to give his speech. And Mr. Zakaria, you will have 20 minutes. So the organizers asked me to keep time. So at 18 minutes, I will give you a very gentle reminder. Please.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good morning, distinguished colleagues, fellow panel members, and esteemed participants. I was informed it's only 10 minutes. I was prepared for 10 minutes, but that's okay. Maybe the other speakers can continue speaking after me. So first and foremost, it is a great honor to join you at the International Symposium on Sustainability in Engineering Education, where our shared mission is to shape engineers of tomorrow, engineers who will not only design and build, but also protect, restore, and future-proof our world. And the urgency of this is real. And then the UN 2030, for instance, agenda challenges us to reimagine engineering education so that sustainability, ethics, inclusion, and resilience are not an add-ons. So technically, this should be in our curriculum, but the very DNA of our graduate mindset and practice. So here is where the International Engineering Alliance, IEA Graduate Attribute and Professional Competency GAPC version 4 comes in. This is basically the international benchmark that now places sustainability at the heart, what it means to be the competent engineer. In Malaysia, for example, all engineering programs are accredited by the Engineering Accreditation Council, EAC. So technically, this is a council operating under the BM. And the EAC has fully adopted the latest EA Graduate Attribute and Professional Competency. This is basically the framework that explicitly links engineering competency to sustainability, ethics, inclusivity, and lifelong learning. So the EAC Accreditation Standard 2024 that we launched last year aligns directly with the JAPC Graduate Attribute and Knowledge Profiles, ensuring that sustainability is not a standalone subject, but is embedded across curriculum, assessment, and graduate capabilities. It means that this approach, the program outcomes in our standard now directly mirror the sustainability emphasis in the JAPC. And the sustainability attainment is verified as part of accreditation. So it's not just, we don't just assume that the IHL will then implement it or ticking the box, but something that we want to see to be implemented across the curriculum. And the institution, the universities must demonstrate that continuous quality improvement CQI using feedback from stakeholders, including industry, alumni, and professional bodies. When we talk about the JAPC 4.0, sustainability appears not as a single attribute to be taken off, but as for us, it's a golden thread running across multiple graduate attributes. We have, for example, WA2. We talk about the problem analysis that call for a graduate to examine the complex engineering problems. With the holistic consideration for sustainable development, we have WA3, for example, design development of solution that requires a whole life cost thinking, net zero, carbon strategies, and cultural environmental sensitivity. And then we have, for instance, WA6, the engineer and the world, that makes it explicit that the graduate must evaluate sustainable development impact to society, the economy, health, safety, and environment. And this is all directly linked to the 17 United Nations Sustainable Development Goal. So this is reinforced. We have the WA that reinforced by the knowledge profile. So we have a list of knowledge profile, for example, under the GAPC, we have WK5 that addresses efficient resource use and environmental impact. WK7, for instance, focuses on engineers' role in society, and WK8 emphasizes adaptability and lifelong learning, essential for staying relevant in a world where sustainable challenges are constantly evolving. In Malaysia, our accreditation framework under the EAC reflect the same vision. So the EAC Accreditation Standard 2024 integrate this sustainability-driven outcome directly as a program outcomes. So for a program to be accredited, it must go beyond delivering lectures about sustainability, but it must show that students apply to it, demonstrate competence in it, and that the process is continuously improve. This is not an abstract or expectation. In fact, our curriculum already has two. We built in two powerful mechanisms in our curriculum. We have what we call it the Integrated Design Project, IDP, and the final year project. The IDP is basically a capstone team project that brings together multidisciplinary students to tackle a complex, open-ended problems. And the final year project allows students to go deep, often over 2 semesters, applying research methods and technical knowledge to produce an innovative solution. Both of these are perfect platform for embedding the UN SDG elements. So we can design a project brief, for instance, that align with specific SDGs, for example, renewable energy system, SDG 7, accessible entities and accessible cities communities on the SDG 11, or affordable and clean water solution in SDG 6. We can require students, for example, to apply the triple bottom line, evaluating the environmental, social, and economic impacts of their solution. So we encourage culturally sensitive and socially inclusive approaches, ensuring that our graduates think beyond purely the technical. So this is not just a theoretical. Imagine an IDP where students work with a local authority to design a flood resilient drainage system for flood-prone township, addressing both SDGs, for example, climate change and sensible systems communities. Or when we talk about the final year project where students design a low-cost solar-powered cold storage for fishermen in a rural area, for example, directly supporting SDG 2, zero hunger, and also SDG 8, for example, we talk about decent work and economic growth. These are not a simply academic exercise. They produce a resolution with potential for the adoption and then nurture graduates who can step into the industry ready to address Malaysia's and the world's pressing accessibility challenge. So in Malaysia context, for example, the strong framework, we also draw from the real world example. So when in our curriculum, for example, encourage that when it comes to teaching, the collaboration between the academician and the academic and industry to bring the sense of accessibility to life for our student. I'll give you an example. For example, in our latest development, we have what we call it Sarawak Bali Hydroelectric Project. This is not just an engineering feat. It is a textbook case on how a large-scale infrastructure project can align with the Sustainable Development Goals. So basically, when we talk the student about the SDG, we don't just explain. We then use the real life example, how the particular SDGs to be applied into the real world case. So basically for this particular project, for example, this hydroelectric, we talk about the SDG 7, for example, affordable and clean energy. And technically, it significantly boosts the Sarawak renewable energy capacity, providing a clean long-term power source. We have SDG 8, decent work and economic growth, SDG 9, SDG 12, responsible and consumption and production. It incorporates environmental impact assessment and mitigation measure into every stage of development. So projects like this offer our students more than theory. They show them that sustainability principle can and must be embedded from design through the operation. So when paired with integrating indigenous knowledge system, for example, applying traditional rainwater harvesting methods from rural area alongside modern filtration technologies and religion collaboration, such as joint mangrove restoration efforts across the Strait of Malacca, we can give our student comprehensive perspective. So from this, from an accreditation standpoint, embedding sustainability into integrated design project and final year project gives tangible evidence of programs outcome attainment. So basically, if you look into the latest JAPC, for example, PO3, design and solution, PO6, for instance, talk about the engineer in the world. So this is how we want to see. So basically, during accreditation, we talk to the lecturers and animation. We want to understand how they apply this SDG element, if you like, into the curriculum. We then triangulate with the student, because it's one hand that the lecturers might explain that they might apply the certain element of SDGs into their certain courses. We want to understand that how does the student actually understand the sustainability element? How do they apply into their project? So when they talk about their project, we ask them about how do you apply the certain element of SDG into your project? So do you consider the society element into it? Do you consider about the renewable energy into it? And how do you choose certain method that relates directly to the sustainability? So from the accreditational standpoint, it developed critical thinkers. So ethical decision makers and lifelong learners. So basically, and also from the societal standpoint, every graduating class leave behind portfolio and context relevant. Basically, a sustainability-driven solution, a living legacy that grows year after year. So, when we apply the sustainability-driven goal, we look into the accreditation standpoint, from the educational standpoint, but also from the society. How does actually the project from the students actually benefit the society at large? So in overall, when we talk about the graduate attribute and professional competency, it gives us a blueprint, because the latest JAPC, when we talk about the knowledge profile, the complex engineering problem, it emphasized the SDG element into it. It gave us a blueprint for all of us around the world to follow. And in Malaysia, for instance, the EAC standards give us the structure. So basically, because we adopt the latest JAPC into our standard, it gives us a structure. And the project, like for example, the integrated design project and the final year project, give us the platform to bring idea into life. So our regional collaboration turn the classroom into a shared space without borders. So we start with the blueprints, start from the JAPC, for example, and the standard give us a structure, and the two element into the curriculum, for example, the integrated design project and then final project, give us a platform for the student to somehow bring their ideas, and how their ideas not only assist the industry to solve the problem, but also the society in large, because we want the student, when they conduct their project, not only a project that purely a research base. This is something, so they use the real industry problems through their research, and the solution benefit the society. So the challenge is now is to make this project more than just graduating a requirement. We don't want that because this requirement is in our standard, that the university think that, okay, this is like a tick in the box. This is that we must have, that we must do. We want to go beyond this thing, because we want to make them as engines, as a mechanism of real changes. Because we want to connect what students learn to the needs of our communities. So basically, it's a link between the students or the academician with the industry. And we believe that if we do this well, our graduate won't just join the workforce when they complete their study. They will shape it, bringing the skill, mindset, and values that needed to turn the sustainability development goals into reality. We want the SDG to be not just on paper, but reality that assists, that give the opportunity for students to excel, to turn their ideas into the reality, and to assist the society and the industry in large. Thank you.
Thank you very much, Mr. Zakaria. You have give us ample of time so that we can utilize this later on in our discussion. Thank you very much again for your excellent presentation. And we will come back to the discussion. Let's hear from the speakers first. Our next speaker is Professor Krishna Vedula. Professor Krishna Vedula started his study long time ago. He received his PhD in 1980. It was in materials engineering from Michigan Technological University. Later, of course, he joined the academia. He was a professor and Dean Emeritus in the Department of Chemical Engineering, Francis College of Engineering, University of Massachusetts, Lowell. Professor Vedula has contributed enormously towards this engineering education. He is a fellow of both American Society for Engineering Education and also International Federation of Engineering Education and Societies. He received many outstanding awards, notably Outstanding Engineering Educator in 2003, Indus Star in 2002, Must High Tech All-Star 2001, and also Workforce Development Leader of the Year 2000. Professor Vedula also was Vishesha Professor of Engineering in 1993 and contributed to many, many international conferences as keynote speakers. So with his vast research experience, we very much look forward to hear you, sir.
Okay, thank you. Thank you, Dr. Haseeb. I assume you can hear me?
Yes, very well.
Professor Zairul, Aslam.
Yeah, okay. How are you, sir?
Good to see you. We have a lot of connections.
Thank you, thank you.
Thank you, and thank you for your nice introduction, Dr. Abdul Haseeb, and I thank Engineer Zakaria for setting the stage for some interesting discussions. Let me point out that after spending 40 plus years in the United States in academia, I have returned to India. So I'm now based in India, in Hyderabad. Last 5 years I've been in India. And I lead an organization which is called the Indo-Universal Collaboration for Engineering Education. And we've been doing this even while I was in the United States, but now I work with it full-time on a voluntary basis in India. So this topic of sustainability and engineering education is very close to my heart, both engineering education as well as sustainability. So thank you for giving me a little time to share my thoughts with you. Hopefully this will be useful to the panelists and the members of the community that is part of this conference, particularly Zairul University of Science and Technology. And I hope there are many faculty and students out there listening to what we're talking about, because this is really important. That's one of the most important things that we can talk about in the world nowadays. There are so many changes happening in the world. Most importantly, I think our students are changing a lot. Our students are changing a lot, and the world has changed a lot. And clearly it says that we have to have major changes in our own engineering education system because of that. We cannot continue to teach our youngsters the way that I was taught, or some of us were taught in the old days. We have to change how we teach. And that's a very important part. So I want to address the engineering education portion a little bit first, and then lead it towards the sustainability. Mr. Zakaria very efficiently talked about how the connection between accreditation agencies and how that helps engineering institutions move more towards sustainability education and design thinking and project-based learning, and how the projects can then contribute to the accreditation process and the improvement of quality. But I want to step back a little bit and talk about the mantra that we have in India. IUC, we have a quote saying, "I am teaching, are they learning?" That's the basis for what we stand for. I'm teaching, are they learning? And this is meant for faculty, because if you go back to the time when we were students, when some of us, I can see a lot of gray hair that we have when we were students in our classes, and even today, the faculty tend to teach in a way that has been taught for many years, where they stand up on the stage, give a lecture, students sit, 60 students sit in a classroom patiently for the whole lecture, and somehow at the end of that, we assume that they're learning something, right? This is still happening all over the world, including America. I'm not talking about any. It's just in the United States itself, we have these things happening. But that way of teaching, it does not really lead to proper learning. I think that has been, research has shown that, and I think it is time for our faculty to learn how to teach. If you reflect on it, we all become faculty members without having taken a single course on how to teach. So we need to help our faculty teach in a way that the students are actually learning. And that's why we have this mantra, I am teaching, they're learning. If they are not learning, then I have to change how I teach. And a lot of research by eminent educators all over the world has shown that this traditional format of just giving a one-way lecture for 50 minutes does not really work because of how the brain works. And so the brain can only take information in small chunks. And therefore, you have to have lectures which are sprinkled with short activities, which get the students to use your information that you provide in such a way that they can absorb the information and store it properly in their permanent memory, and eventually be able to pull it out and use it for something useful. Okay, so that is the focus of what I call student-centric teaching rather than faculty-centric teaching. We have to change in that direction, particularly nowadays where we have students who are so absorbed in technology and the iPhone, and now they are being completely engulfed with artificial intelligence. We have to be creative in how we work with them to make them learn more effectively. And I think this continuous engagement of the students in a face-to-face mode, not just an online, but a face-to-face mode when we're in the classroom, engaging with the students continuously so that they develop the skills, that ABET and all the accreditation agencies will appreciate. We have critical thinking, communication, teamwork, innovative thinking, and all of these are really the foundation of education, and particularly engineering education, and of all the accreditation processes all over the world. They look for evidence that we have taught our students these professional skills, and not just some content which is just memorized and pass exam. Because that content changes every year. They have to learn how to develop these skills, which people like Engineer Zakaria and others in accreditation agencies have really, I think they emphasize that. And so going to the next step, beyond just the one having a student engaged in a classroom, now we have to think about how do we engage them in a larger manner into some project. Okay, that's where project for sustainability comes in, right? So and those will also, and that particularly strengthen the teamwork, project-based learning skills, communication skills, ethics, so project management, and then all innovative critical applications and so on. All of the things that are listed in all the various documents that ABET, NBA in India, and all the accreditation agencies all over the world, they have similar things on the list. Okay, so I want to emphasize one particular process, which again I think many of you are familiar with. Sometimes it comes in a different name. I saw somewhere in your publications you talked about CDIO, conceive, design, implement, and operate, right? So I'm not that familiar with that particular way of details of that, but I spend more time on the concept of design thinking, which is very similar. And I think it's important for us to teach our students this process of project-based learning, design thinking, CDIO, right from the first year that they enter college. Not just wait for the final year project then to learn those things. Okay, so design thinking really is a very powerful tool for students to develop all the skills that are needed to become useful citizens of the world, and whether they work for the industry or for society or for government. It's a very powerful tool to develop the way of thinking about a particular problem. And in this context of today's conference, I think they can apply this. I encourage all the students in the colleges that I work with. We have about 50 colleges all over India associated with what we are doing. And we work closely with the faculty and students, faculty development student projects. We encourage all of them right from the first year to have design thinking courses and start introducing them to sustainability projects. Grand challenges, all those things are there. You don't have to look at anywhere and far away. Every student, every college is surrounded either by cities or rural areas which have these problems that we face today. Water, energy, air, etc., any of the sustainable development goals, right? They're there, real life projects all around us. All we have to do is encourage the students with guidance from faculty to identify some of these projects and start finding small solutions to them while they're students. So then they take up the skills of problem solving and design thinking to their lives later on, and whatever they do, then they'll be able to contribute on a larger scale to the improvement of sustainability in the world. Okay, to make the planet more sustainable. So in design thinking, if many of you are familiar with it, at the risk of repeating the three items, the first step is very important. Okay, identifying the problem. The first step, identify the problem. It's not, and we never teach our students in the 4 years of education normally to identify problems. Just give them a problem and say, okay, use these equations and solve it, right? Identifying the problem requires a very enormous amount of thoughtful skills, where they have to work with the community or the person or the industry having the problem. Okay, that piece is completely missing in many times when in our colleges, the faculty teach students how to do project-based learning. They have to empathize with the community that's facing the problem, or with the individual that's facing the problem, or with the industry that's facing the problem. So that first part of empathizing, empathy, and that's not a technical skill. They have to learn a social skill of empathizing with the community, with the which is facing the sustainability skills like clean water or air or garbage, waste management, whatever that might be. Go to the community, empathize with the community, and understand the problem, what exactly the problem being faced, and then define the problem. Okay. And once they've done that, then you have to go in there, and design thinking is to research on why is the problem happening. Once you define the problem, and why is it happening? What are the reasons why this, why we have so much polluted water in this particular village? What are the reasons why we have so much air pollution in this urban area? Why does it do all these places have this enormous amount of garbage or plastics and all these places? Whatever it might be. And then once you do that, then you start trying to say, okay, now I have to, once I understand the reasons and I empathize with the people who are having the problem, now I have to come up with possible solutions. Okay, and this whole process is a very important process in learning how to deal with real world problems, learning the skills of engineering, learning the skills, professional skills that are required. And they will do that by critical thinking, by thinking of reasons for communicating with each other, having discussions with other students about the problem, and then listening to the customer, communicating with the customer, asking them the right questions, doing the right surveys. All of these just now allow them to really understand the problem, and then start thinking about why it is happening, and then start listing possible solutions. And that is where innovation comes in, innovative thinking comes in. Okay, now you have to think innovatively, think of some existing solutions that are out there. Many times students look at a problem and they say, well, immediately just jump to a solution. I have the answer to this, right? We have to slow down. Okay, no. Just think a little bit. Okay, very often, many of those solutions already have been tried in different parts of the world. Let us understand what has been tried in different places, do some research on that, and learn some lessons from what worked, what did not work, what is the context in which that problem was addressed, and then use that information now to apply it to your own situation. Many times, students they want to solve the whole, the worldwide problem all in one semester, right? There's not a complex thing they want to think, it's not very famous in one semester. No, slowly take a small piece of it and find an innovative approach to it, and incremental change, incremental improvement. And design involves a lot of incremental changes, solutions, and then come up with a list of innovative ideas that you can implement solutions to that particular problem, right? And then the question comes in. Now you have to use the critical thinking. Which of these problems will work? Which of them will I implement, right? It's not enough. So I have to look at those different possible solutions. Use critical thinking. You say, this is too expensive. This will take too long. This involves this thing. We don't have resources for this, and so on. So there will be different ways of having a matrix of analyzing different solutions, and this develops this engineering training of thinking of possible solutions, analyzing it, and communicating it, and debating among each other as to which of these solutions is a possible solution, and then on the point of trying to implement a solution. Okay, and that is where again it is important to not think of building something huge right away. It's important to think of building a small prototype, test it out, Okay, you found some possible solution, build a prototype. Okay, it might be virtual, might be a little model, it's cosmos model, and build something that that can be shown to everybody and discussed. Not just an idea. Okay, build a prototype, go to the village and say, this maybe might help decrease the pollution or improve the clean water or whatever problem you're trying to solve. And then go, that's the point where you have to go back to the problem is happening. Go back to the people who are facing the problem and then get their feedback. Then they will realize, oh yeah, right, now what I said earlier is not quite right. What the problem we're facing is this and this. And so then you have to go back and modify your prototype, modify your solution, and you might have to do this several times. So the design thinking process is a cyclical process where you have to interact with people and improve your design gradually to get to the point where you have a solution that is that makes sense, reasonably affordable, and actually can be practically implemented. Now, this whole process sounds very good, okay, on paper and talk about it, but in most institutions around the world, including the United States, faculty have difficulty guiding students to go through this process. And that is where I think it's important for our faculty anywhere in the world to learn how to guide students through this process of design thinking and select a few sustainable areas in their villages or cities nearby and build teams. And I think if they do a certain number of these kinds of things, they will definitely, that institution that is promoting this will get enormous benefits in terms of engineers, graduates who are extremely valuable to society, and the institution itself will be well recognized as someone who really understands what education is about and fits all the criteria that BUET or other organizations are saying are required for outcome-based education nowadays. So that's really I think it's now excellent opportunity for global skills to be developed by taking this kind of an approach towards improving the sustainability. And eventually these youngsters will go out into the world, become leaders of countries, leaders of industries, and be able to promote and champion excellent policies all over the world. So with that, I'm going to stop. Okay, and hopefully I made a point, hopefully, and hopefully it will be useful. And I'll be happy to chat some more during the discussion. Thank you all.
Thank you very much, Professor Vedula, for covering this wide landscape. And we will come back to you during the discussion. We have the next speaker, Dr. Javeed Kittur. He's an assistant professor at Gallogly College of Engineering at the University of Oklahoma. He received his PhD in 2022 in engineering education. I think it was in engineering education systems and design. Please correct me if I'm wrong.
Engineering and systems.
Yes. And he has research experience, extensive research experience in engineering education. He received different awards, like in 2024, he received Student Government Association Outstanding Faculty Award from the University of Oklahoma for his excellent teaching and mentorship. He also received a prestigious award from Transformations in Engineering Education, and it has a very special name. Dr. Javeed Kittur will probably help us understand this. ing.paed.igip. Dr. Kittur also served as associate editor of the Journal of Engineering Education Transformations. So with this brief introduction, I welcome Dr. Kittur to present his case. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. Am I audible?
Yes, you're audible. Thank you.
Listen, thank you, everybody. Thank you for this opportunity. I'm really honored to be sharing this panel with amazing speakers like Mr. Zakaria and Dr. Vedula. I've had a long association with Dr. Vedula. I think it's more than a decade now that we've been working together and I'm really happy and excited to be on board. Let me try sharing my screen real quick. Both the speakers have set the stage really well for me to get started, and I think I will dive deeper into this particular topic where I'm trying to talk about how at the University of Oklahoma we have integrated United Nations Sustainable Development Goals in the engineering curriculum. Are you able to see my screen?
Yes.
Yes.
Okay, perfect. So in this presentation, I'm going to walk you all through the specific course that we at the University of Oklahoma teach to our undergraduate students, where we have intentionally integrated UN SDGs. To give you a quick background, at our university, we have the sophomore course, which is titled as ENGR 2002, titled Professional Responsibilities and Skills for Engineers and Scientists. We also call it as Professional Development. So this is essentially a mandatory course that we want all our engineering students to enroll in. And this is a lab course, meaning we'll have 2 class meetings every week, each close to 2 hours. So approximately we meet 3.5 hours every week with our students. And this course is really heavy on project-based learning. And we extensively use flipped classroom approach where students do a lot of readings and they complete some tests or they respond to these prompts prior to class on the course learning management system, and they come fully prepared to the class period. And we use those basics and get started. So teamwork is also one other essential piece of our courses. It's heavy on teamwork as well, where we have 5 students working in a team. Even though we meet every week twice for close to 2 hours for each class period, we have very small lecture time, which is 15 to 20 minutes. And a lot of the time that goes in these classes is work days where students sort of work together in teams on the projects that are related to UN SDGs. So this course specifically has 4 learning outcomes. And here I'm talking about each one of them one by one. One of the things that we want our students to learn is acquiring and applying new knowledge. So as a part of the 3 projects that they will be working, which are related to the UN SDGs, which I'll talk about shortly, one of the things that we want them to know and do is constantly learn to acquire and apply new knowledge. Because as engineers, we want them to firstly be really proficient in acquiring the knowledge, because there's huge database, huge literature available online. But then we want students to learn that as they're going up in their engineering degree. And in this particular course, we specifically walk them through one database, which is Web of Science, where we train them to retrieve articles related to the UN SDGs and apply that as they're working on their projects. The second piece that we focus in this course is communication. As we all know, communication is really important, and we want all our engineering students, our future engineers, to be really good in communication, which is both oral and written communication. As I said earlier, the course is heavily focused on teamwork, and we use this awesome tool which is developed by Purdue. It's called Comprehensive Assessment Team Member Effectiveness. So this particular tool has some inbuilt questions, but as instructors, you can always edit, add, or drop some questions. And based on those survey completion, you can form teams to make sure you have really good representation of team members in every team. The last piece that we focus as a part of this course is we want students to be able to make decisions ethically, which is an important piece for every engineering student. So as I said, in this specific course, we are intentionally integrating UN SDGs, and we have a very structured approach where we want students to work on understanding what a UN SDG is, what a United Nations Sustainable Development Goal is. At the same time, we also want them to understand how important it is for them as engineers to understand these goals in the first place, and also what role they would play in solving these sustainable development goals. So the first piece, or the first project, is just for them to identify and select one UN SDG. So as there are 17 UN SDGs, every team is going to select just one UN SDGs. And if you go to the UNSCG website, you will see all of these goals, and each goal has several targets. So students are required to just pick one and sort of work on that target. So we want to make sure that not every team is working on the same goal and the same target. We're okay with students working on the same goal, but we want them to at least pick up a different target. So as an instructor, and I have a TA in my class who help me mentor my student teams. So we make sure that no two teams end up selecting the same target, but we're okay with them selecting the same goals. So as a part of the project one, as I said, they will identify and select one UNSDG, then select the target. Additionally, we also want them to select the metrics and indicators, which will help them understand that, okay, by achieving these metrics or indicators, which could be quantitative, qualitative, depending on how those metrics are proposed. And we want students to understand, like, by achieving these metrics, this goal will be achieved. So again, students do a lot of literature in this. That's why the first focus, that is acquiring and applying new knowledge, is important, because we want them to understand how to do that. And just because every team is probably working on different UNSDGs or different targets, we want them to educate the entire class through PowerPoint presentations, which brings us to the second main objective, which was communication. We want them to improve in their oral communication. So as a part of project one, these are some of the things that they do. Again, so on this slide, you see these 17 goals, and as Mr. Zakaria already talked about a few of these. So as I said, students get to pick any of these. And these projects that our students are working on they're not implementing anything hardware. All of it is just doing literature and proposing some solutions. So project one runs for 2 weeks, 2 to 3 weeks. And then we move on to project two, where students build on that identified UNSDG, that one specific UNSDG on the target, and they're now tasked to propose a technological solution. So this solution can be an existing solution, it could be a hypothetical solution, or it could be a combination of existing solutions, or it could be something really brand new, right? So when we say technological solution, we don't necessarily mean that students have to have a solution that uses some technology or some software. It could be something like a hardware solution, which is fine, as long as everything that they're talking about is grounded in the literature. That's where, again, we go back to the first point of focus, which is acquiring and applying new knowledge. Every claim, every argument that students make as a part of this course has to be really well grounded in the literature. There has to be literature backing their arguments that they're making. So they just cannot say that, for example, solar energy could be a potential solution to one of the problems, but then we want them to explain to me as an instructor and to the TA, as well as to the entire class, how or why solar energy is a potential solution. We want them to go back, read some literature, read some papers, and give us that rationale, that reasoning, that justification as to why they think that specific solution will help us meet the UNSDG. So as a part of project two, they're also required, in addition to doing extensive literature research, they're also required to make a presentation just like project one, where they're further educating their peers and helping them understand what solution might help answer the identified UNSDG. So through their presentation, they get evaluated from the instructor, TA, and the peers. So there's a lot of feedback that they get from the three people, that's of course the instructor, TAs, and as I said, their peers. And as I spoke about using CATME as an awesome tool for helping them form teams, CATME has this amazing feature where students can provide feedback. It could be constructive, it could be areas for improvement, or if they like to praise their team members, they can do that as well. So again, this has been really, really helpful. And again, as I said, teamwork is also an important piece for us. So we have, I as an instructor meet with each of these teams after every project presentations and coach them on the areas that they can further improve. All of this discussion is still grounded on the UNSDGs, but we're also focusing on their overall professional development. So we are intentionally integrating students to learn about UNSDGs, understanding the impact that they can create as engineers on these sustainable development goals, but at the same time, we're also helping them learn these professional skills. So unlike project one, in project two, students also are required to write a report. And again, on this report, they get feedback from both their peers, the TA and the instructor. We also want them to improve their written communication. So unlike project one, as I said, so that's the additional piece that they do here. Project three is focused on performing stakeholder ethical analysis. So once they've proposed the technological solution for the UN SDG that they've identified, now we want them to identify stakeholders who might be affected with the solution. So they pick up stakeholders between 3 to 5. So we look at the downstream stakeholders, more so could be essentially individuals. We don't want them to go super broad. We want it to be related to a specific person or team members, because they can take their perspectives and talk about how the ethical analysis or the decision making that can come into picture. We do a lot of hand-holding in the class in terms of we do like a mock role play of stakeholder perspective analysis, where we want students to understand how to do that. So when I say project-based learning as the approach that we use, there's a lot of learning that they have in this course, which they eventually apply onto their projects. So again, we use a tool called as Markular Tool Ethical Analysis Toolkit, where they essentially apply 5 ethical lenses, and they view these stakeholders from those perspectives. And again, they sort of make a presentation again at the end, which is their final presentation, project 3 presentation, where again, they're educating their peers. They get feedback from peers, instructor, and the TA, as well as they complete the CATME surveys and give feedback. There's also report writing. If you look at this course, as I said, we're trying to achieve 2 things. With one is, of course, creating an awareness about the impact that they can have as engineering students in achieving the United Nations Sustainable Development Goals. And at the same time, we are trying to educate and help them understand and appreciate the importance of acquiring and applying new knowledge, working in teams. We talk a lot about team conflict or management styles and all of those things, because we want them to be effective team members. We talk about shared leadership. We talk about how important it is for them to understand the difference between oral and written communication, and irrespective of whatever career path they choose, eventually the communication is really, really important. And we try to instill that through this course. And finally, making decisions ethically, which is also an important piece. So we talk about that as well. So this was my last slide. I'm now open for questions. And yeah, I look forward to talking more about what we do as a part of this course, and I'm happy to share more insights as questions come up. Thank you for this opportunity.
Thank you very much, Dr. Kittur. I think to give us a very detailed overview of a particular course where you target these SDGs. I think we have a very rich presentation so far that covers a very wide spectrum. On the one hand, Professor Vedula started with his wide educational approach on design thinking, which has a lot of applicability, including in this particular SDG related education. And then we have in Malaysian practice, where SDG is not targeted in a specific course, but covered comprehensively in different courses, culminating in design project and final year project. And then Dr. Kittur presented his innovative course, where he targets SDG in that particular course. With this rich layout of the whole thing before us, I think our learned participant will now jump in with a lot of questions. So we encourage questions. Please do come in.
May I ask a question? Who are the participants? The faculty at your university, or broader than that? Who are your participants right now?
It's both, actually. We have many faculties actually joining us in our physically here, and we have some other things as well.
Okay.
Okay, Prof. I have a question.
Please identify yourself,
Yeah.
because others.
No, thank you. Thank you very much. I was just going through the latest report from UNDESA about the bleak picture about the SDG achievements. It came out very recently, I think in July last month. Yeah, it's giving us a very bleak picture. If you allow me to show you, I think it will trigger something among all of us. So this is from this very latest report coming. Why? Yeah, this one. the Sustainable Development Goals Report 2025. And then this is the overall progress across targets based on this 2015 to 2025 global aggregate data. So you can see here only, this is green is the on track or target made 18%. And then you see what's happening to other range, moderate progress, marginal progress, stagnation, regression, all this. If you look into the other overall, so this is the scenario. The green, little bit, not significantly green. Yeah, in all these goals. If you go and look into the individual, targets, yeah, for different SDGs, 17 SDGs. Yeah, so you don't see green, that much green in different SDG indicators. Yeah, the scenario is quite, it looks like quite bleak, I would say. So I would appreciate if you can comment about this and what we can do as educators in engineering education to alleviate this disastrous situation, I would say. Thank you.
I think it started that. Yeah.
Professor Vedula, would you like to go ahead?
So there's a famous quote that I use when you're surrounded by this kind of gloom and doom. I say, don't complain about the darkness, light a candle. Okay? Let us light a candle, all of us. Okay? If you look at the history of all these problems that we are talking about, climate change, air pollution, water, it has been over millions of years that these have happened. Okay? It's not something that happened last 10 years or 20 years of these problems have evolved and come upon our human beings because we have been not very careful all these years. And only recently we have started to think about these issues. Let us be patient. I think there are a lot of young people who are learning about these things and learning to improve these things. And let us have faith in the future generations that things will change. There's no need to be pessimistic. I think we can make a significant dent, each one of us, in what we do. Okay? Keep up the hope.
In fact, that makes it even more relevant for us to put extra efforts to teach our students who will be the leaders in the coming years.
Yeah, if I may add, I think these goals were set to be achieved by 2030, and as Dr. Vedula said, I think we are in the direction of achieving these goals, but it's going to take us a while as there are several factors that are coming on the way as we're trying to solve these problems, and these problems are complex, right? Even though we just say, for example, we want to work on the first UN SDG, which is reducing poverty, for instance. There's so many factors that come into picture when you're trying to address that. So even though it might just sound that, okay, we're trying to reduce poverty or provide education, but it's not as easy as it sounds. And we are trying to achieve these by 2030, but there's several dynamics that are coming in. And hopefully, as even Dr. Abdul Haseeb said, we have to educate our future engineers to be ready to solve these problems and understand the timeliness of solving these problems in the first place. I think as students, when I graduated, I rarely remember my instructors talking about sustainable development goals. So I'm not saying my teachers were bad. It's just that was not intentionally instilled in my thought process that as an engineer, I would be solving these problems and catering towards sustainability or sustainable development goals. So I think as educators, we have a lot of responsibility on our shoulders to make sure that we make our students aware in the first place and help them sensitize with the urgency of solving these problems, or at least being prepared to solve these problems. Thank you.
Thank you very much, Dr. Kittur. Mr. Zakaria, would you like to add to this? We have to dispel all this despair.
Yeah, like mentioned by the panels, that the issue of accessibility has been there for a long time, but it's only recently that make it more bold. For us, there's a lot of involvement by industry and for in our role, for example, because we are the accrediting body, we have the authority and the power, if you like, to encourage the IHL, because it requires a lot of support from the governments. And in Malaysia, for example, for new project, the requirement of SDG and ESG must be placed. So, and also that's why through our accreditation, we want to make sure that IHL, that not just ticking the box, we want to make sure that when they implement the SDG element into it, it's not just something that we have to do because it's a requirement of accreditation body. We want to do it because we want to contribute to the society. And I think in time, hopefully soon, we can see that that graph will increase significantly. Thank you.
Thank you very much.
There is
So-
one question. I mean, there is one question from a professor here at OST, Professor Dewan. Yes.
Assalamualaikum. Thank you for your presentation, Professor Dr. Javeed. I was very interested and interesting topic actually, I think. My question actually, you say the students of your project, that's course, particular course, they have selected particular goal but different targets. My point actually, if we are particularly for from specific discipline like mechanical or electrical or CSC, how the students can set their goal, because the field is different. It's very difficult for particular discipline to set one goal. In that case, multidisciplinary students can make a for that particular setting the goals, and then they set the different targets. So I think in that case, they may have better interest to do some better study and teamwork and eventually better outcome, I think. What do you think?
Yes, yeah. Thank you for asking that question. That's a really good question. So at our university, the University of Oklahoma, this course is a required course, as I said, and students enroll based on their availability. And we have, I think, 9 to 10 sections every semester that this course being offered, and different professors teach this. So students are free to choose the time slots that work for them. So generally we get a mix of students. So it's rarely that we get the entire class of 40 students, everybody from chemical engineering or mechanical or aerospace or electrical. So there's generally a mix that's already there. But sometimes we've also seen where they were either dominated by computer science students or a mix. So yes, as I said, we use this tool called CatMe, and as instructors, we can set that as a parameter where we make those team, one of the requirements for those teams to be formed would be that the students are from different disciplines, so that students from different disciplines come together and try and propose solutions that are unique, creative, and at the same time multidisciplinary. Again, it's important for us to understand as instructors that these are just second-year students, so they do not have a lot of technical or engineering background per se from their discipline specific. So we cannot expect them to talk a lot in terms of the engineered solutions. They're still trying to propose solutions, but yes, going back to your question, I think we've seen in the past that it's always good to have students from different engineering disciplines to be put together in one team than just students from one specific team, because they start complaining, I'm a biomedical engineering student. I don't necessarily would know a lot about, let's say, aerospace related stuff or mechanical engineering related stuff. So I think it's always good to have teams from different majors, and they can bring in a lot of perspectives from their majors, but they're still novice in terms of the knowledge that they are up to date with respect to their specific major, but it's still good to get started with multidisciplinary teams. I hope that answers your question. Yeah, Krishna, you want to say?
Yeah,
Can
please,
I
Professor.
add? Although this was a focused question for my good friend Javeed, I think it's typical of a question that a faculty member might have among all our institutions all over the world, as to how to actually, in a classroom, implement these things, okay? And it goes back to the earlier question, how do we scale up the process? How do we speed up the process to do this thing more rapidly? What we have to do is have discussions like this, but at the same time, bring in examples of success stories at different institutions all over the world. There are institutions, and I know Zakaria knows about many institutions that have excellent work is being done in addressing the sustainable development goals. So our challenge is to get those examples out there and get our faculty, like the gentleman who spoke a little bit earlier, give them an opportunity to understand what works and what does not work, and help them, train them, guide them, motivate them, and reward them, most importantly, because a lot of these kinds of things do not get rewarded. More faculty do not get rewarded for doing these exciting things. They get rewarded for publishing research papers in super scientific journals, but they don't get rewarded for doing some really good projects that are related to sustainable development projects. These need not necessarily result in Scopus Index papers, but they result in movement towards solving the sustainable science. So we really have to have an ecosystem where good examples are brought out to the community, and then individual institutions will help motivate their own faculty with these examples and train them, educate them to make it happen. Just want to make that comment. Thank you.
Okay, which means in the case of Dr. Kittur, so your course is multidisciplinary, and it is given even before the student have chosen their tracks in engineering. Is that
So,
correct?
well, yeah. So at the University of Oklahoma, so students get to, some of them come as undecided. They have that freedom and flexibility of coming into an engineering college without deciding an engineering major, right? But generally, the first year is where they are exposed to a lot of preliminary and basic fundamental courses around engineering that would give them the flavors of different engineering majors. So then they can pick and decide. But some students still change their majors when they're in their second year. So, but again, unlike, so I'm an Indian. So when I studied in India, we had like a specific course for, I'm an electrical engineer. So all my classmates were electrical engineers. So we were taught a course and everybody was electrical engineer in my class. But here at the University of Oklahoma, students get to choose the professor that they want to study with. They get to choose the class they want to enroll in. So there's a little bit of different context and setting where students get to choose. And as I said, most times it so happens that the students that we see in our classes are from different engineering majors. So we don't intentionally do anything to get that diverse representation of engineering majors in our classes. It naturally happens because students end up choosing the time slots that work for them. We start our classes at 8:30-ish. Sometimes we go up till 7:30 or 8 in the evening. So there are different time slots, 2-hour time slots. So somebody who's available in the evening will take a class in the evening. Somebody who likes morning classes takes a morning class. So yeah, so we have that leeway and freedom of having students who are by default from different majors. So we don't have that constraint where that every student in our class is from one specific major. But if that's the case in the university where you guys are, maybe you can offer an elective course where you can have students enroll from different majors. That way you keep that as a requirement or a criterion to have this course run.
Okay. And administratively, how is it managed? Is it managed by the College of Engineering or?
Yes. So it is managed by the College of Engineering. As a faculty, I don't have control over which students come into my class.
Okay. All right.
I'm just assigned a few sections that I'm required to teach, and I have 40 students that I don't have control over. So yeah.
Thank you.
Mr. Chairman, can I ask a few questions?
Please go ahead.
Okay, the first to Dr. Kittur.
Yes.
So when you introduce this 2 credit hour course, is it adding on top of the existing credit hours, or it is replacing some other courses?
Well, it isn't replacing any course, so it's a part of the overall credits that they have. So it's a required course that every engineering student has to take if they want to graduate. So if a student
total credit hours are not affected.
No, it's a part of the curriculum itself.
Okay, because that is the big challenge so far everywhere. If you want to introduce a 2 credit, even 1 credit is a headache.
Absolutely. I've worked in India for 4 years, so I know the struggle. We've always been trying to bring down the credit. So I totally understand that concern for sure.
Okay, to IR Zakaria. So you mentioned to distribute this sustainability in different courses. But to my understanding, without a primer course somewhere to define what are the SDGs, so what are the targets of SDGs, all these things in a theoretical course, maybe it is a half credit hour of 1 credit hour. Without doing this, if you just distribute across the board, students will miss the issue of SDGs. That is my concern.
I think for us, because we are the accrediting body and we leave it to the IHL, because IHL, the university, is the people that know their subject, their program. And also, we think about, for example, mechanical. We have so many mechanical programs across various universities. We do not want to produce a similar program. Some universities might want to be specialists in manufacturing, for instance, and some might be in agriculture, and some might be in aerospace. So their focus on SDG will be different. So, I mean, for us, what we want is basically, we want the element to be there, but we don't specify in which subject and etc. So when we talk about a subject, for example, we want to make sure that, because not all subject you can implement SDGs, and then not all 17 SDG you can implement, can be easily implemented. Some SDG require machines and etc. that some universities might not be able to afford it. But I mentioned earlier that, for example, when we have the integrated design project and final year project, this is where the combination of various SDGs that we want to be seen to be implemented. Because, like, say, for example, you talk about the SDG, about the SDG 2, for example, zero hunger. You have the a combination between mechanical student, chemical student. So the aim is basically to fulfill the SDG 2, zero hunger. But mechanical student will approach it differently in comparison to chemical student, for example. So, but although all of us trying to achieve one goal, but how we solve that will be different. Because I believe the university has the specialty, because some universities, the professors might be inclined to one subject than the other. But we want to encourage the university to implement the SDG from the beginning. So when the student comes to year 3 and year 4, they're already well versed, rather than they implement it towards the end. Then when they're trying to implement it, they'll say, what is the SDGs? We want the students slowly, gradually understand the SDGs. When they come to implement it, they are already well versed to it. So that's my perspective. Thank you.
Okay, thank you all.
Okay, thank you. We need more questions.
Can I ask something?
Please go ahead.
Well, I think this question is geared towards Professor Krishna and maybe towards Javeed Professor Javeed as well. See, you're from India and we're from Bangladesh, and I think in many ways we, as people, face the same challenges. We have a developing country with an enormous population, and in many ways we've seen pollutions, unsustainable development, many issues. So, first of all, how do other countries, say, Japan, Korea, and many ways China, will face big troubles? They have gone so much further than us, and we struggle in this field. And also what we've seen, and I'm not very proud to admit this, maybe I'm looking at this, but we've seen a big exodus of talent from these sort of countries. You know, you study here and we see them going to Europe, Japan, the US. So how do we retain that talent while promoting sustainable development, while promoting development? And in many ways, look, the socio-economic situation in India and Bangladesh and Pakistan is so bad. How do we ensure that what comes first? Do we actually care about sustainability, or we just want to put the food on the table? Thank you very much.
Javeed, you want to go ahead? Yeah.
Please, Professor Vedula.
Go ahead.
Okay. I mean, the question, I'm trying to rephrase the question. And how do we, can you give me the bottom line?
Basically, how do we face the challenge? How do we ensure that we can retain our talent in Bangladesh and India, while developing in a way that we can not only put these people out of poverty, put these people development while being sustainable? Because we've seen incredible amount of pollution when we see outside, for example, outside of university campuses, in many ways polluted. So how do we develop the country while we pull these people out of poverty and ensure that we do it in a clean and sustainable way, like you see in, say, Europe or Japan or maybe in America?
Let me point out though that if you look at some of the statistics, the world's most developed countries are the largest polluters. They are the biggest column in terms of sustainability. Where the poorer countries don't produce as much solvent as the more developed countries, and so they have to start figuring out how to do these things. And if you look at all the political ramifications, the meetings that take place, they're the ones who are not keeping up the goals and moving things in the direction. So we cannot beat our heads on that unless they can. It's part of a larger political economic situation where really the free enterprise industry, all of these people who want to make a lot of money doing whatever they do, they are polluting the world. So making money is actually an important contributor to all the problems we face. So we have to really cultivate in our youngsters, for the future generations, okay, this balance. Okay, it's okay to make money so long as you have this what we call design the cycle, where you have all the elements of sustainability built into everything that we do. Okay, that's idealistic, but I think we have to continue to strive to get our youngsters to thinking about everything that we do. How can it be sustained in a sustainable model, so that recycle, reuse, all of these things are there, are remanufactured, taking many of these kinds of kind of words and teaching our youngsters in our colleges, since we're talking about engineering education, focusing on these kinds of things. And that is why it is important. I think somebody pointed out earlier about the number of credits in the system. I think education institutions should take serious look at the number of credits that they have in the system and modify that so that they have enough room to educate our students about the multidimensional aspects of starting in business and keeping it sustainable. So it's a long journey. Javeed?
Yeah. So if I may add, I think firstly the question is super broad and it has several layers to it in the first place, right? So I think as an educator, let me share my perspective from an educator's point of view. So I know university back in India where they're trying to promote sustainability and they're trying to have a green campus. So I think it starts from within as to how we set it. Of course, it's difficult to change the entire system or the entire thing, right? But just to start with, as a university, we can probably set some ground rules. For example, avoid using plastic, avoid wasting papers or stuff like that, right? So you can have these small little policies on your campus, have more trees, have more plants, right? So this university that I was talking about, it's called Hyderabad Institute of Technology and Management. They have they call it as a green certified campus, where be it their construction, they use very little electricity. The construction is so well set that there's natural lighting. They don't use plastic and stuff like that, right? So I think if you try and practice what we're preaching, I think our students are also going to appreciate and learn that and see the value in doing that. So I think that's something that we can get started with eventually. It's easier said than done, but I think as educators, there's always a first step that we have to take, and there's definitely, as Krishna said, it's a long way to walk, and we all have to do it together.
All right. Next question.
Any question?
Let me go back to Mr. Zakaria. From educators' point of from evaluators' point of view, what pointers do you look for in order to decide that, yes, this program has attained this outcome, particularly related to SDG?
Okay, when it comes to SDG, what we normally do is basically we talk to the lecturers, we talk to the academician, because the academician will explain that they're doing everything like that. And after that, we then triangulate with the courses itself, the mapping and etc. So basically from there, we have ideas, okay, from the explanation from the lecturers, from explanation, this is what they are trying to, implement the SDGs element into a certain subject, certain courses, and it's proven through their record, through their, what we call it, course resource file. In the end, what we do is basically we talk to the student, because at the end of the day, you can tell a great story, but if the student doesn't get it, meaning that the outcome is not achieved. So although most of the time when and most of us probably from academia knows that we would like to tell that we did everything and everything, but at the end of the day, does the student actually get it? So at the end, we have to talk to the student. We ask the student, for example, certain particular we ask in a way that not directly that do you know what SDG is, because most of them they're probably the lecturers already told them SDG is 17 SDG, you must know, they memorize it. So we calculate in a way that we look into, for example, the pollution, for instance, or we talk about the now we're talking about AI, we talk about the gender equality. And we want them to give the opinion, and from their opinion, they will know whether the student actually get it or not, and whether the SDG element embedded into them. Because in the latest GIPC, when we talk about SDG, it's not something that we can't measure all of them, but we want to make sure that the student is fully aware of it. And I think to go back to the question I previously asked about the situation in Bangladesh and India, and you made comparison into the China and Japan and etc. I think each one of us, each country has their own problems, even in Malaysia. But the most importantly, that Dr. Javeed earlier, it starts from the academic. The education, it plays a vital role, because the student, when they go to university at the age of 18, 19, they are at the age where you can nurture them. And everything has to start from yourself. You as an examination, what you yourself in your class actually contribute to SDG, because a lot of the time when we talk about SDG, we are trying so hard to actually implement it, and we want the student to implement it. But when we look at ourselves, do we actually implement it ourselves? And most of the time, like sometimes simple thing that when you go to the shopping, you don't you reuse the plastic bag or that sort of thing, that actually us as educator play a vital role, because the most of the time the student will look at as they idolize the academician. They look at someone that they would like to follow. So, but if we don't do it, they were thinking that why should I do it? Because my lecturers doesn't even do it. So why should I? So it's very important that I think from that perspective that we want to see the SDG. We in Malaysia, what we always mention is the culture. We want to see the culture. It become a part of you. It's not something that you do because you want to pass to get a degree, but it becomes your NDA that you want to contribute to the SDG.
Good.
Thank
Good.
you.
Excellent comment, Secretary.
Thank you very much, Mr. Zakaria. Very well said. So it has to be built into our psyche. It has to be a culture, not just a few courses. More questions? We still have a few minutes to go. So maybe I can again jump in. So Professor Vedula, you are very passionate about design thinking. Please tell us a little bit more. How do you dispense this? Is it in a course? Do you also combine it with entrepreneurship? Tell us a little bit more on this, please.
No, it's essentially, actually my good friend Bill Oak, who's at Purdue University, he's the guru of design thinking, and he has a program called Engineering Projects and Community Service. And a lot of those projects are related to sustainability. And so in many colleges all over India have started this thing of design thinking, 2-3 credit course like Javeed at Stone, something like that. And so they learned in the first year. And so the building, the 4 stages, as I said, right? But they have to pick a specific project. And as Zakaria said, they have to start working on the campus itself. First, make your campus sustainable, right? So they have to start looking around and say, what are the trees, the wastage, plastic, the water, air on the campus itself, make it clean and green. So the goal should be to make it clean and green, right? So the design thinking course starts having the students look around themselves. then on the campus. They will not even go outside campus. Sometimes they could, but they can just on the campus itself and identify small specific problems and empathize with where the problem is being felt. And then the faculty members will take them through the various stages of empathy and then guide them through the process of inquiring about what is the reason for that problem, and then coming up with different possible solutions, and then building a prototype. That's important. Usually in the first year, they may not get to that, but in the first year, two or three credit course, they will get to the some solutions. And then maybe in subsequent years, they learn to build prototypes. And by the time they get the final year, they might be able to, teams might be able to get to much more sophisticated projects that are solved. So it's happening in various colleges all over the world, but in India, in our 40 institutions that we're working with, slowly we are getting that done. We have some folks who have background in sustainability. One of our global experts is now working with the team to get students to compete. So we have a design thinking project competition on sustainability. And so just recently we floated that competition for this year. About 141 projects were submitted from our 40 colleges. And then they are kind of fine tuning them down to about 20 projects that they are going to mentor specifically. These are industry colleagues of mine who are going to sit with each team and talk with them. So this is the level of intensive interaction that is needed to get the students to get to the point of doing something useful. That's what I meant by I'm teaching are they learning. Not enough to just give them a book and say memorize this and pass an exam, but you have to be engaged with them. And so by December, we're hoping that at least 20 of these projects will get mentored, and at least 4 or 5 of them will really get to a point where it makes a lot of sense. And we have an annual conference every year, physically in Bangalore this year. Many of them will come together and talk about these things. But again, we have to also keep in mind that there is this whole elephant in the room, AI, artificial intelligence. We have to use it in a positive way. We have to make sure that we can take advantage of that, and the students will use it, right, to move us towards more sustainable environment. I just want to stop there. I know the time is running out, and I could go on and on and on.
Excellent. Thank you so much. Professor Mazhar, you have something to say.
Yes.
Yeah, thank you. Thank you, Prof. I have one question to Prof. Vedula. One thing I learned from him a long time ago, I mean, he delivered a presentation here in Bangladesh and he talked about the informed design process. I learned it from you, sir. Yeah, I didn't know about it. And then I took it very seriously. Even I was sharing the clip from your video with my colleagues and I tried really hard to popularize it here in our institution. And I am implementing this in our machine design sessional. I have my 2 students, they have done it, informed design process. I think we are one of the few institutions in Bangladesh who are implementing it and doing it seriously, informed design process. So regarding incorporating SDG, if you have some comments in this informed design process framework, which is awesome, how can we do it? Any tips or suggestions will help us, hopefully.
This is for me or for Javeed? Javeed has come from a college in India called the ETAC University, where they're doing an excellent job of these kinds of things. Do you want to give some examples that you might be familiar with, Javeed, at ETAC University?
Yes. So we back at ETAC in India, so we were teaching this course called as Engineering Exploration, which is a freshman course where we had several modules and several units that were integrated. The students still work on a real-time project, but then it had a lot of aspects to it, right from introduction to engineering analysis, platform-based development, multidisciplinary nature of engineering design problem. And engineering design process was at the core of the course. So we did a lot of hand-holding in terms of coding and all of those pieces. I think it is possible to, again, intentionally integrate it into any framework, provided we walk it through in a structured approach with our students. And we've seen a lot of success with that course, and that has been one of the most popular courses back at ETAC. And a lot of universities in India have copied that course eventually. And I think it's really helping students shape their perspectives on engineering education right from the freshman year. and then eventually they do a lot of courses at sophomore year, which is more so applying in detail about the engineering design process, design thinking, and other specific courses like that, which help them understand and appreciate more of the engineering process than just reading what's in the book. Yeah, in the interest of time, I'm trying to restrict my response.
We can, Professor Zairul, we can connect you with a couple of colleges who are doing these things in India. And I'm sure Javeed can connect you with some people in the US, and I'm sure Zakaria can also connect some people in Malaysia who are doing excellent. That is what the purpose of meeting like this is, to connect people to where some success stories and best practices, and that's how we learn. Okay.
Thank you. Thank you very much.
All right. I think that
Yeah.
brings to us exactly at 11:30. That was the time given to me by the organizers. I thank you all so very much, particularly our three excellent speakers who made this session enriched, I believe. And I also thank the organizers, Professor Mazhar and his team, for organizing this great two-day event. And I thank you also the organizer to ask me to be associated with this. With this, I give it back to you, the organizer, please.
Professor
Good job.
Mazhar.
Okay.
Good job, Dr. Haseeb. Yeah.
Dr. Haseeb, I'm Professor Muhtin.
Hi. Yes,
Yeah. How are you?
I'm doing fine. Thank
Okay,
you.
fine. I joined late actually in this talk. So I want to put one question after this, if you permit me.
Okay. If
I
the
want to
organizers
know-
allow me, please give us a few seconds. Please go ahead.
Just to talk about SDG and sustainability. Can you SDG is a big spectrum of sustainability issues, but sustainability in some projects you can use sustainability. But if you talk about SDG goals, 17 goals together and sustainability, it will be very tough for us to accommodate in our curriculum. So our curriculum, engineering curriculum, should be multidisciplinary and integrated way in 2 or 3 courses. Sometimes every department wants to design curriculum, but it is very difficult to address all these sustainable goal issues. So I'm suggesting you how we'll incorporate sustainability in civil engineering courses, mechanical engineering courses, or integratedly multidisciplinary way. Which one will be better? Do you understand what I'm meaning?
I think some of the questions were answered.
Already discussed.
Indeed, it's a big issue, but I think towards the end, the organizers will not allow us enough time because you raised the big question. Of course, it cannot be taught in a comprehensive way. There has to be.
You can continue if you want. We can give you
approach. Can we continue?
Yeah, absolutely, sir. We can get some time. No worries.
All right.
Yeah.
In that case, the speakers. Do you?
Yeah, I mean, I think the important thing to realize is that we cannot do everything. Okay, we have to start small. Essentially, we cannot put all the sustainable development goals in the institutions. We have to pick a few, but we have to train up. The
Yes.
key is the people, the youngsters that get trained to think in a certain way that they will solve these problems. That is what our responsibility is during the 4 years, not to try to address all the 17 sustainable development goals. Pick a few that are doable with practical examples around the campus, around the places they live, include them in your curriculum, and get the students to become aware and trained so that when they graduate and go into various jobs all over the world, they will use that training, the way of solving problems for common society, to go to broader levels and cover all sustainable goals. Okay, so we just have to get them going, and they will do it. We just have to get them moving. Okay?
What I understand, sustainability doesn't mean you have to fulfill all these goals. Sustainability means you have to work with society and economic and environmental issues. If you sometimes people confused about the SDG and sustainability together. I don't like that. That's why I'm saying this. that is a separate issue. Sustainability goal is a different issue. It's a global issue. It is very wide spectrum. Sustainability should be based on his or teachers' subjects or departmental subjects way. I mean, it should be, as you said, that it should be project-based or integration of 2 or 3 problem-solving matter. So we don't want to relate with the sustainable SDG. Sometimes people confused. I think I am confusing. I'm feeling confused whenever you talk with the SDG goals and sustainability together.
Just pick 1 or 2 or 3,
Okay,
that's
thank you
all.
very much.
Yeah.
Professor,
Thank
I
you.
think
All
I
right.
just give
Dr.
my simple input. When we have our grading system, 50% is a recognized a pass. So if you give 17 sustainable goals, the students still will learn 3 or 4. So don't worry. So as long as they know what are the sustainable goals, they know that there are 17 sustainable goals, they don't need to memorize. And a few they implement relevant to their department and the project. I think that will be the essence of this idea of sustainability. We cannot teach this because there are departments of sustainability who are considering all 17 sustainabilities. We are a program and we are struggling with credit hours. If you want to include just 1 or 2 credit hours in the current structure, then we have to accumulate somehow. You cannot just increase the credit hour. So it is basically still, it is a touch and go. As long as we have the 50% grading for pass mark of a student, he will answer the one bottom line, he will answer 50%. The other 50%, of course, he will not learn. Okay, thank you very much.
All right. I think we have to end somewhere.
Yeah,
this is a
Thank you.
good
Allow
point
me, Dr. Haseeb.
where we
Thank you,
have
Dr.
start of a discussion. So please, let's continue this discussion. And thank you very much once again.
Thank you very much, Prof.
Goodbye.
Thank you.
See you all.
Thanks to all our panel members for their valuable contribution to the discussion session. It was truly a captivating session. Now, I would like to hand the mic over to my fellow coordinator and my classmate, Arnajan Choudhury, to conduct the concluding session.